talk about benzene reactions, or more benzene reactions that we can have. So one of them is benzylic bromination, and if you remember back when we talked about radicals, especially when you would treat, say, an allylic radical, I'll just go ahead and draw out what I'm talking about here, but remember when you treated an allylic radical with, say, N-bromosuccinimide in light or N-bromosuccinimide in peroxide, you'd always get this mixture, right? Well, with this, you don't get a mixture. You get a direct result. So say I take this compound here, this carbon-hydrogen bond. This is allylic. If you look at it, it's the same thing. It's part of a benzene ring. And I go ahead and treat that with, say, N-bromosuccinimide and peroxide. No, it doesn't have to be this. It could be Br2 in light. But anyways, I'm going to cleave that allylic carbon, or radically cleave it, the allylic carbon-hydrogen bond. And instead of getting a mixture like I did with a non-benzylic allylic carbon, I'm going to get a straightforward reaction that gives me only one product, that I'm going to have my Br there. I'm only going to get one product, and so that's a reaction that I like. That's a reaction that I am happy to see. This here, I run this here in peroxide, and voila, that's all that I have to deal with. So pretty helpful. Next thing I wanted to talk about would be oxidations of alkyl groups that are attached to benzene rings. So let's just say, I'm just going to use it as a very generic, it could be any alkyl group, but I'll just use methane as an example, or a methyl group, sorry. So say you have a methyl group here, and methyls are pretty unreactive. Say I wanted to either try to find a way to put something at a meta position, or maybe I just wanted to learn about one of those reactions that I'm going to hopefully divulge in on later with carboxylic acid. So if I wanted to convert this to a carboxylic acid, I just go ahead and treat it with some classic potassium permanganate, and what I get is a carboxylic acid attached to my benzene ring. So cool. And this works with this will cut any carbon-hydrogen bond. This cuts any carbon-hydrogen bond pretty smoothly. So now let's talk about reduction. And this is going to be, I may not have room for this. I hope I do. But there's two types of substituents that we are going to be reducing on benzene rings, and that is ketones and then nitro groups. Nitro. So let's just talk about ketones real quickly, if we can fit it down here at least. So say I have, well, not that, but a ketone, which is formed from Friedel-Crafts acylation, or acetylation. I don't know why I can never pronounce that right. And the problem with the Friedel-Crafts alkylation is that if I wanted to attach a primary, just a straight chain of alkyl groups, I can't do that because of that carbocation shift. It's going to be quite a pain. But I can do some type of a reduction reaction that's going to convert this right here into, if I can draw it, oh, that looks ugly. But anyways, CH2R. And the way that I do this, generally speaking, is to take NH2, NH2, sodium hydroxide, and then some heat, and that'll convert that to there. Another way that I could do this, or I could use, just for this part here as a reducing agent, I can use zinc mercury amalgam in hydrochloric acid. But a lot of substituents, apparently, what I've been told at least, tend to be very acid sensitive. And then for nitro groups, I'm going to go ahead and just do that on a different page. But the one last thing I wanted to say on the subject of reduction of ketones is that this reaction works great for ketones only. This is for ketones only. This does not work for esters or amides. So I'll just go ahead and draw that out there. Not for an ester group or an amide group, and that'll make sense later. Two ways that we can do this, and depending on the circumstances, you may want to run it in a different direction. But the first one that you can do, get NO2 group, and then you react that with H2 and palladium on carbon, and you have just successfully converted a very toxic NO2 group to a NH3. I'm sorry, an NH2, not an NH3. So let's say that you're doing this reaction and you have a halogen attached to your benzene ring with your nitro group there. And you go ahead and treat it with H2 palladium carbon, and this will cleave that halogen bond. It's going to totally destroy that. But let's say that for whatever reason you wanted to keep that halogen attached to it. Well, that's okay. You just do the same reaction. It's going to do the same thing. It's going to totally get rid of that NO2 group that's super toxic. But what you can do is you can treat it with iron and hydrochloric acid, or I think that's tin and hydrochloric acid. It's the same thing. Well, I mean, the product is the same. They're not the same element. I didn't draw that as a ring. Whoa, that was weird. And so what you get out of this is an NH2 and a Cl attached to it, and you get to keep your halogen, which is nice.